Hey everybody, Mr. Reeves back with you in my third and final. I promise this is the last video on lesson 16.3, interpreting the unit rate as slope. After my last video, I decided I really wanted to do one more example. Actually, it's going to be two examples of finding and comparing unit rates, because this is really a super duper important idea to understand, and a lot of your understanding in algebra going forward will be based on this. So if you don't get this now, you're going to have a harder time later. Okay, so we've talked about there are four representations of a proportional relationship. You can have the words or the verbal representation, you can have a table, you can have a graph, and you can have an equation. And if you're really good, you can get any one of those representations and turn it into the other three. And what's so important about that is a situation like this. So I'm given these two machines that are producing gallons of milk. Actually, they're not producing the gallons of milk. They are simply bottling the gallons of milk. And one of the rates is given in a table, and the other rate is given in a graph. All right? And we want to be able to compare them, so we need to get them to look the same. So we either want to take machine 2 and make a table, or machine 1 and make a graph, or maybe, just maybe, we'll do both, right? All right, so if we take a look at machine 2 here on the graph, if we wanted to find some points, first of all, make sure you always pay attention to the scale. 2, 4, 6, 8, 10. This is going by twos. And when you're looking at a graph, try to find a point that is both on the graph, the line, and on the grid. On the line and on the grid. And sometimes it's not real easy to see. But if you look carefully, it sure looks like if I go over 1, 2, 3, 4, and I go up 1, 2, 3, that I'm on that line, right? Doesn't it look like that? If you think you're right, then what you could do is repeat the same process and see if you're back on the line, right? Over 1, 2, 3, 4, and up 1, 2, 3. It sure looks like that's what works to get me on the line, right? So those points, if I take a look at what I have, this point right here would be 8, 6, right? 8, 6, and this point right here would be, let's see here, if we go 4 more, we're going to be 12, right? And if we go up 6 more, excuse me, we went over 8, my apologies. If we go over 8 more, we're at 16, right? So 0 to 8 is 8. 8 plus 8 is 16. And then going up, we went up 6. If we go up 6 more, we're at 16, 12. And if you go straight across, you can see right there, there we are, right? Because we're going by twos. All right, so that, I'm pretty confident that those are points that are on the graph, some data points that might come in handy, okay? All right, so what we're going to try to find is we're going to try to find the slope and the unit rate for each machine. Now, machine 1, they are given a table. Just a reminder, slope is the change in y over the change in x. It is the rise over the run. If it's a proportional relationship, it will be the constant of proportionality, right? It will be the constant of proportionality, right? And remember, it also will be the unit rate. All those fun stuff. So if we find the slope, we will know the unit rate. All right, well, on a table, right, we're going to call this our x and this our y. We can confirm that. You could see that the time is our x and the amount of gallons is our y, right? What is our change in y right here? It is 0.6, right? 0.6, 0.6. And what is our change in our x? Plus 1, right? So our slope is 0.6 over 1, or 0.6. All right, by the way, if you wanted that to be a fraction, you don't necessarily have to have a fraction. That would be 6/10, which would be 3/5. All right, so that is our slope. That is our unit rate. Now, unit rates, you want to actually put the measurement, the units of measurement on there. So we have a number, that number, and I'm going to go ahead and write it as a fraction. 3/5 what? 3/5 gallons per hour. Did you know Santa Claus is coming to town? He is. All right, so machine 1 is 3/5 of a gallon per hour. That is the unit rate. All right, remember we do y over x. So if you're going, well, wait, time is above gallons, but remember it's y over x, or change in y over x. So machine 1 is 3/5 of a gallon per hour. Now, how do I find the unit rate on machine 2? All right, well, I could do the same thing. I could take these 2 points, and in effect, what I've done is I've just created a mini table right here, right? If I put time and if I put amount here, I've come up with 2 points, haven't I? For time, I have 8, and for amount, I have 6. And for time, I have 16. And for amount, I have 12. So I could do the same thing here and do change in y is 6. Change in x is 8. And I could do 6 over 8. And I can simplify that to 3/4. So I could say the unit rate for this one is what? 3/4 of a gallon per hour. Right? All right. So that is one way to do it. When you start with the graph, you can take some points off the graph and put them in a table and find it that way, change in y over change in x. You also, and probably the more common way, because it doesn't require you to get the points, is you can use the slope. Again, it's very important you find 2 points that are on the line and on the grid. That's what you want to work with, okay? On the line and on the grid if you're going to count. It's really important. All right, so how much did I go up? I went 3 boxes, but remember it's 2. So up 6 and over 4 boxes is 8, right? So even if I hadn't written that number there, I know that I went up 6 and over 8. And as we showed over here, 6/8 reduces to 3/4. And remember, when you are finding the slope, you can use any 2 points you want to, right? I could have skipped all the way and gone like that, right? I could have used those numbers and used 16 and 12, or 12 over 16, because it would be change in y over change in x. All right? Okay, so if I then asked you, okay, which one is going at a faster rate? Well, I've got 3/5 of a gallon and I've got 3/4 of a gallon. All right. Well, if you fill up 3/5 or if you fill up 3/4, which one is more full? Right? 3/5 or 3/4. Well, they're both 3, but this is 3/5. This is 3 out of 5, and this is 3 out of 4. All right. This is where going back to the decimal would be good. That's 0.6, and this one would be 0.75. Do you agree that 0.75 is bigger than 0.6? But just to make sure, just to show it visually, let's put this one on the graph. All right? Now, if you're going, well, wait, how am I going to graph 0.6 and 1.2 and 1.8 and 2.4? You know what? We're not going to. What happens if we multiply all of these by 10? We can get a proportional relationship. We can get an equivalent fraction, right? So if 1 is 0.6, 10 would be 6. Do you see how that works? And 2 is 1.2. 20 would be 12. So I'm going to use these red values as ordered pairs. So my first one is going to be 10/6, right? And my second one is going to be 20/12. So I'm going to go 10, 2, 4, 6. It's right there. And 20, 2, 4, 6, 8, 10, 12. And then if I draw that line in, can you see that that red line is lower than that blue line? So what does that tell you? That tells you that its unit rate is lower. And you remember the blue one, that was machine number 2. And the red one was machine number 1. So we just visually confirmed on the graph that machine 2 has a higher rate. We already knew that. Machine 2 is 0.75 or 3/4 of a gallon per hour. I should check that with blue, right? And machine 1 was over here at 3/5 of a gallon per hour. 0.6 is smaller than 0.75. All right. Okay, I was thinking I was going to do 2 examples, but I hit that one pretty thoroughly. So I think we're just going to call it a day. So you can find the unit rate from a table. You can find the unit rate from the graph. Oh, one more thing. You know what I didn't do? I didn't do the equation. I didn't do the equation. So what would the equation be for machine 1? All right, what was its unit rate? Remember what it was? All right, the unit rate, which turns out to be the same as the constant of proportionality for machine 1, was 3/5, right? So the equation for machine 1, y equals 3/5 x, or if you wrote it as a decimal, y equals 0.6x, all right? For machine 2, do you remember what that slope or unit rate or constant of proportionality turned out to be? It was 3/4, right? So the equation for machine 2 is y equals 3/4 x, or if you prefer as a decimal, y equals 0.75x. There we go. Okay, so now we have the graph, we have the table, we had the equation, and we could say it in words as well, right? We could say machine 1 bottles 3 gallons every 5 minutes, and we could say machine 2 bottles 3 gallons every 4 minutes, right? It does the same number of gallons in 1 less second, not minutes, second. All right, definitely time for me to stop. I hope this video helped you. I hope you had as much fun as I did. Probably not. See you next time. Bye.